This is Mr. Hanna. Welcome to What Format. Today we're going to do some more completing the square. So I have complete the square up here. Normally, when I was in school, as I remember it, this is when I used completing the square for this application I'm about to show you. They've since extended that. It's one of the 5 ways now to solve a quadratic. The reason why I'm not a big fan of completing the square for solving a quadratic is because when you take y equals ax squared plus bx plus c, and apply completing the square to it to solve it, guess what you get? You get the quadratic formula. So in essence, in my mind, using the quadratic formula is actually completing the square. It's just already been done for you. So at that point, you just have to plug the numbers into the quadratic formula and do the math. So if that's already been done for you, why complete the square to solve it? On one hand, I can see you learning it just to see how it was done, but to use it on a regular basis, to me, it feels a little bit unnecessary. Unfortunately, you'll find that today in algebra, so whatever your teacher asks, you want to be able to do it, even if sometimes it doesn't make sense, okay? Real life application, you're going to have a boss that asks you to do things that you think are kind of dumb, or in a way you're dumb, but if you do them, you keep your job. You don't do them, you lose your job. So there is a real life application that sometimes we're asked to do something that doesn't quite make sense to us, but it's easier just to do it and not argue than to argue. But the reason why I point out that this is why I learned completing squares, because this is a very important thing. We have to be able to go from standard form, this is standard form, to vertex form, okay? Standard form right here to vertex form. That's often asked. And to that, you need to do completing the square. Well, technically there's another way to do that too, but I think completing the square is probably the easiest way with that. So there you go. But of course, as I say that, then some other people will say, well, no, the other way is easier. So I'm only going to show you this way right now because with Algebra 1, this tends to be something that's necessary. Completing the square is what you're learning. Another video at some other time will go show you the x equals minus b over 2a way. But for now, to not confuse the issue, we're just going to use completing the square. So very important that you recognize there's a couple different steps with this process for going from standard form to vertex form than there is for solving. Okay, again, you do want to know how to use completing the square to solve, but if given a choice, and I'm just asked to solve a quadratic with any choice up to me, I'm going to try to factor it first, and then if it doesn't factor, I'm going to use the quadratic formula. Or if the factoring, because the numbers are too crazy and I can't see how it factors, I'm just going to jump in right in the quadratic formula. Why? Quadratic formula works all the time. I'm a big fan of using a method, the method that works all the time, being very consistent and solid with that, because then you can solve any problem. Even if you can't use the method they're asking, at least you get the right answer. So that being said, standard form to vertex form. So let's start over here. Notice the difference. Here, a equals 1. Right there. See, there's no a. Here, what does my a equal? 3. Now, the way this matters is there's one extra step here. Okay? It's not that big a deal if you can see how to do it, but if you're not careful, it can kind of mess you up. So over here, what I'm going to do is, when I solve, remember I moved that 1 over. We're still going to move the 1 over. We're just not going to move it over where you think. We're going to put parentheses around this. We want our gap there, remember, to complete the square, but we leave the 1 on that side because we don't want to change anything with y here. So we're not going to subtract the 1 over. Now, we still want half of 24. Remember, we want, for completing the square, we want b over 2 squared. Why? Well, that's the pattern. Take a binomial, any binomial, x plus 5, square it, x minus 7, square it. You're going to see the pattern that the back number is that number that you started with squared. So if I start with 5, 5 squared is 25. The middle number is always going to be double that number. So 2 times 5 is 10. Okay, so if we know we start with double the number, going backwards, the opposite of doubling it is cutting it in half. But we have to have that number squared on the end. So here we go. Half of 24 is 12. And that factors down to our binomial square. And you try it. Set that out in square. You're going to see you're going to get a minus 24x because you're going to get minus 12x not once but twice. So, but on the back you have to have a certain number. What number is that? This number squared, because if you square this, you FOIL it. 12 times 12 is what? 144. So there's your plus 144. Now, when we were solving, we added 144 to the other side. Again, we can't do that here. So what do? Well, we do the opposite. The opposite of plus 144 is minus 144. 144 and 1 is your minus 143, and guess what? You're done. How can you do that, Mr. Hanna? Well, 144 minus 144 is 0. I added 0 to this side of the equation. So, what's the name of my channel? What the format? This and this are the same thing. They don't look like it, but this trinomial factors down to this. So they're the same thing even though they don't look the same thing. So now if you multiply this out, you're going to get this, x squared minus 24x plus 144. And then the 144 minus 143 is going to give you the what? The plus 1. So you're going to get right back to this. So these are the same thing even though they don't look like it. So that's how you complete the square. So what's different over here? Well, we're going to do the same steps as we did there, but we have to get the 3 out first. And when you take the 3 out, that has to be divided by 3. So we didn't have to do that over here because we had the 1. So we pulled the 3 out. Now, you're still going to take half of b, but now your b is 8 instead of 24. Why did I change it to 8, Mr. Hanna? You're factoring the 3 out. You're only factoring it out from these right here. So you're dividing this by 3, and you're dividing this by 3 to get it into the front. See? The front right there. So if I divide that by 3, there's my x squared. I got to divide that by 3, the 8x. But what about the 1? No. You don't want to divide the 1 by 3. You want to pull it out. See, that's why I put the parentheses here. You only want the greatest common factor of the numbers here. You don't want to pull the x out either. So be careful not to make that mistake. This is not a factoring problem. You're not doing the greatest common factor here. And even if you were, this doesn't have an x in common or a 3. So normally you wouldn't do that in this case. We're forcing these to be together. We're taking the greatest common factor of these two numbers, which is 3. Okay, that's the steps. That's the process. Now what's half of 8? 4. So then that's going to be your x minus 4 squared. See, you have 24, x minus 12 squared, half 8, x minus 4 squared, right? Now if this is a plus 24, this would be plus 8. All we do is change that to a plus. This sign matches what we start with. So be careful on that. Don't change it as you go down. Now, to do that though, I needed a what squared? 4 squared. So what's 4 squared? Plus 16. See, b over 2 squared. There's your b over 2. There's your b over 2 squared. Don't subtract 16 out here. Well, I thought we do that, Mr. Hanna, we did it over here. But you have 3 times 16. You got to multiply those first. You actually added 48. Here, multiplying by 1 times 144 is 144. That's why we didn't have to change that. Here we had a 3, so that was really plus 48. So we're going to do what? Minus 48. That goes to minus 47. And guess what? So it's actually a lot simpler to me, in my mind, than solving, because you don't have to do that whole square root thing and worry about simplifying any radicals. You're just changing the format. Much simpler steps. Difference is you have to remember it's still b over 2 squared, but you have to remember you have to stay on the same side. Okay? So you just do the opposite. So whatever you add in here, so you can factor it down to here, you have to subtract out there. Whatever you add in here, you have to subtract out there, but you have to remember when there's a number in front, after it's factored out, you have to multiply the 3 times the 16, which is your AC, which if we've been in the factoring videos you've been watching, you notice that sometimes you have to multiply the 8 times the c. Well, here it is again. And you'll notice that these two a's are the exact same. See, it was 3x squared here, it's a 3 here. It's a 1x squared here, it's a 1 here. And that's always going to be the case, because the way you go from standard form to vertex form is always factoring the a out, so you'll have the a in front. And just don't forget to do this division. I see a lot of students pull the 3 out and keep this as 24. And then now you're going to be wrong, okay? And you're going to have 3 times 144, so you make the math even more difficult for yourself and the number's bigger. Please just be careful. But here you go. These are the steps. This is why for me, when I was in school, completing the square wasn't a big deal, because I think this is pretty straightforward. When you're solving it, it gets a little bit more complicated. Unfortunately, you have to know it today because you might be asked to use it. But if given a choice, I'm not going to use completing the square unless I'm doing this. If I have to solve, I'm just going to use quadratic form. Okay? Again, just remember, if your teacher wants you to do a certain way, just do it. Jump through that hoop. Get your A. Okay? When you move on, you'll have another teacher that says, hey, I recognize that you need to know how to complete the square to solve for some teachers, but for me, I just want you to do it the best way you can. And so you'll either factor a quadratic formula and it'll simplify your life. But again, real life application, not all bosses are the same. Some bosses are just more difficult than others because they're very specific in the way they want things done. And like I said, you have a choice. Do it their way, keep your job, fight them, create friction, eventually lose your job. And then afterwards, you're like, wait, why didn't I just do it what he asked? I mean, it's not a big deal. I mean, I don't think it makes sense, but okay. So completing the square, if I know how to do it to solve, just do it. Maybe I don't do that on my own choice, but at least you know how to do it. But this is, for me, the real reason you complete the square. So it makes it very easy to go from standard form to vertex form. Like I said, there's another way to do it. I like this way. But again, there's another thing. When there's multiple ways to do it as a student, you learn all the ways so you understand them and can do them when asked. Okay? But when given a choice, then you pick the way that makes the most sense for you. And then a lot of times in life, you'll get to do that. Okay? You get to brush your teeth the way you want to in the morning. You don't have to do it the way somebody else tells you to. Okay? Same thing with getting a bowl of cereal or getting dressed. You do it your way. Okay? But there are times in life you need to know certain ways. And there are also times in life maybe knowing a certain way at first looks a little bit harder, but then you find out, hey, I actually like this way. And then that's part of growing up. And that's why I love algebra and the application of algebra, because that's what it prepares you for. It prepares you for other real life things. Even though you're not applying it to algebra at that time, you will be, the skills you learn in algebra, you will apply later. Anyway, hopefully this helps. Hopefully you have no questions here. As always, you can pick up some other examples, but here's one with a equals 1. Here's one with a not equal to 1, and you can see the extra steps, hopefully. Again, if you need to rewatch the video, write it down a couple times, please do it. Any questions, you've got my email, whattheformat@hotmail.com. You can always email me for other examples. And at some point when I get enough content of teaching out here, I'll start doing more just example problems where it's just simple examples and shorter videos. But for now, we need to have the concept, so here it is. Hopefully this helps. This has been Mr. Hanna with What the Format. Happy mathing.